trick.
In this demo, we're going to present you how we leverage large language model on the telecom domain to optimize the 5G network decision making. And basically, we are using the APIs of OpenAI, of the GPT4 model as a foundation model. And basically, what we are trying to do is to optimize a 5G network which is shared. So we have a shared 5G network resource, for example, base stations, and there is the orange stack on the top. For example, there are different APIs in different levels. For example, we have near real-time rig, APIs, non-real-time rig, and the SMO. And basically, we leverage LLMs in different roles. For example, some of them will control the APIs, or some of them will negotiate on top of the resources. The idea is that because the network is shared among multiple business organizations and entities, for example, AT&T, Spotify, maybe Netflix share the network resources, and they have different objectives. So maybe there are some conflicts on top of some resources that are shared. So the idea is that they can use LLM models in order to negotiate on top of the resources. And after here the negotiation is done and there is a decision, the decision is enforced downstream and it goes to another LLM that will monitor and in a closed loop control the network to bring the current state towards the desired state. So if we want to see the demo now, if we start the demo, here we have the 5G network deployed and we have one base station that is shared and we have one UE connected here. So we see the throughput is around 150 megabps. So the two agents will start debating here on the chat. Because they have different objectives, they will give a brief overview of their description, what they want from the network, and the parameter that they want to control, which is throughput in this case. So this one will say, I want a low throughput, I want 40 megabps. The other one will say, I need 75 megabps because I want to prioritize quality of service of my users. And then they negotiate in multiple chat iterations, in a debate, in a negotiation. And at the end, they will reach to an agreement or a disagreement. So, for example, here we can see that they almost agreed to 55 megabps to be enforced in the network. So, right now the network is 130 megabps. So here there is an agreement now, and since there is an agreement, we will send the decision downstream to another LLM. So here the other LLM will try to control now the network to enforce this intent, because it is intent-based networking. So right now the throughput is 140 megabps and we want to reach 55 megabps. So if we start seeing here in multiple iterations, the LLM in a closed loop manner will try to reconcile the network state and control and bring down to the 55 megabps. So we can see here from the application perspective of the UE, it goes down. And if we want to see it more thoroughly, we provide a Grafana dashboard. So here we can see all the metric and provide full observability stack for the network. So here we see the throughput of the network of the base station. Here there is the data volume, and here is the PRB utilization of the network. So we see that after the negotiation at the end, the executive LLM controls the PRB resources in 2 steps, and the PRB utilization is decreased, and so as a result, the throughput is decreased to the decided value. So here we saw how we enforce the desired outcome. So on top of a shared 5G networks, the LLM debate and negotiate on top of the shared resources to resolve any conflicts and to collaborate. So in a multi-agent collaboration environment, automation is done on top of the 5G network, and it's empowered by LLM.
I know there's like